Okay, so next thing we're going to talk about is on 8b.3. I'm going to give you some special log rules. Okay, special log rules, and we're going to graph logs. Okay, so special log rules and graphing logs. So the first rule that we had talked about was basically the translation. So if you have log base b of a equals e, that translates, and you can translate back and forth, to be b to the e equals a. Okay, that was the first one. We've done that one, you know, for the past few days. So that one's one that hopefully you kind of have down by now. So first thing we're going to go over, oops, I'm skipping that. Okay, so for we're going to ask you to simplify these. Okay, so for number 1, if I ask you to simplify log of 10 squared. Log of 10 squared. First you have to put in the missing parts. So there's a base 10. And you can put in an x equals. Okay, if you put those in, you would get 10 to the x equals 10 squared. When you drop the bases, you'd get x equals 2. Okay, that's one's like what we just did. Okay. Try another one. Number 2, if I have log base 7 of 7 to the 4th. Log base 7 of 7 to the 4th. Again, you could start by putting in your x equals, okay, and then rewrite this. X is the exponent on 7. That makes 7 to the 4th. If you drop those, you'd get x equals 4. Okay, are you noticing any sort of pattern here? Any pattern yet? Not exactly. Okay, there's a rule with logs, and the rule is essentially that whenever you have log base b of the same base, okay, log base b of b to the y exponent, it will always equal y. Okay, and this is for all values of x. Okay, now that sounds a little bit abstract, okay? But essentially, I'm going to tell you this is something that I call a Siegel rule. Okay? These are Siegel problems. You are going to like these. Okay? Sonali remembers these. She likes them. These are the easiest problems that I can give you. Okay? You guys know how, okay, so if I have very little kids, okay? So my 3-year-old, if I told her to draw a bird, to draw a seagull, how would she probably draw it? Like a little V like this, okay, right? Like she does like this. Okay? We are going to get very good at drawing seagulls, okay? Because these are what I like to call Siegel problems. Essentially a Siegel problem, all you do, this is very magical, make sure you're paying very close attention, okay? And I'm going to use a different color to get a little brighter, okay? A Siegel problem is if you have the same base and the same number, okay? Same base and answer. You can do this, and that's your answer. Let me show you again, because it was amazing. This one, same base, same answer. Do this, and that's your answer. That is what's called a Siegel problem in my world. Okay, then call it whatever the heck you want to, but I call it a Siegel problem. Okay, these are my 3-year-old seagulls. Okay, call it whatever you want to. It's a rule that works in logs, and it will make it so you do not have to do nearly as much work. Okay, so that will always, by the way, it works for all values. Okay, so this could be a positive, a negative, a 0, a 1, does not matter, a fraction. Okay, it always works. Those are what we like to call Siegel problems. Okay, try another one. For number 3, I would like you to solve log base w of root w. Log base W of root W. Log base W of radical W. Now, I'm going to tell you there's two different ways to do this, okay? The first way is what I showed you in the last lesson. Start by putting in an x, okay? If I put in an x, we would get W to the x power equals radical W. Then what would you do? Write them as the same base, so W to the x equals W to the 1/2 power. Drop the bases, and you'd get x equals 1/2. Totally valid way to do that, and that's fine. But I'm going to tell you, if you embrace the seagulls and like them, okay, your life can be simpler. Because you can do this. You can rewrite this as it's written as a seagull problem. Log base W of, rewrite this with an exponent. W to the what power? 1/2. Then, your little magic ugly seagull comes in. That's your answer. Done. Yes. That is work. Yes. I will count that as work. Drawing an ugly seagull. Check mark, seagull, whatever you call these things. Okay? So this is a shortcut, but it works. Okay? Try another one. Number 4. 2 to the exponent of log base 2 of 8. 2 to the exponent log base 2 of 8. Throw everything out the window here. First thing you have to do is figure out, we have to simplify this exponent, okay? What is log base 2 of 8? How'd you do that so fast? And why do you have my pen? I've been looking for that.
Tyler, you little thief.
Don't eat my pen. Okay? Log base 2 of 8. So in your head, you want to be thinking, what is the exponent on 2 that makes 8? 3. Okay? So you rewrite this as 2 to the 3rd power, which then becomes what? What's 2 to the 3rd power? 8. Okay? That's the answer that I'm looking for here. Okay, so not only are you going to have logs on the bottom, but you're also going to have logs in the exponent. Okay, try another one just like that. Okay, if I give you 10 to the log 100. 10 to the exponent log 100. For this one, what's missing here? The base of 10. So, log base 10 of 100 is what? What's the exponent on 10 that makes 100? 2. So this actually becomes 10 squared, which becomes what? 100 as an answer. Okay, are you noticing another pattern possibly? Good. That's going to give you another rule. Okay. The next rule is that a base to the log with the same base of x will equal x. Now, this is where, make sure that you write down these exceptions, okay? When I write down these rules, basically anytime I write a rule, you can almost guarantee it's going to be on a notes quiz, okay? I'm going to write you an exception though, okay? This only works for some values of x. Okay, for some values of x. X cannot be 0, 1, or negative. Okay, that will only work for some values of x. So essentially, what you can do here is this can be, I'm going to teach you another trick. This can be an upside down seagull. Okay, it's a flying slowly dead seagull. Okay, we have seagulls that look semi like check marks. We have upside down seagulls that look like upside down check marks. Okay, this is gonna be amazing. Watch closely. 2 log base 2. Oh, look, upside down dying seagull, that's your answer. Same thing here. 10 upside down dying seagull, that's your answer. You no longer have to show this work. Not that it's that much work to begin with, but you don't have to do it, okay? This is work. That's it. Circle your answer, done. Questions on how I did that? Okay, same thing here. I want you to simplify. Let's simplify. Lost my page, sorry. Simplify log base 5 of negative 25. Log base 5 of negative 25. If I rewrote this, we want to figure out 5 to what power equals negative 25. 5 to what power equals a negative 25? Is it possible? It's not possible, right? You can't say 5 to any power equals a negative. Okay, it's never going to work. This is undefined. Okay, so 0 with a slash through it. Okay, it does not work. So for this reason, I'm going to tell you another semi-rule here. The rule, or what you definitely need to remember, is that logs are allergic to negatives. Okay? Essentially what that means is anytime you have a negative, oops, sorry, next to or in the base, thank you. Anytime you have a negative on the same level as a log or next to a log, okay? Logs are allergic to them. Or, well, I'm calling them allergic to them, okay? It's basically going to give you an undefined answer, okay? It's not possible. There is no exponents that make them negative. Okay, so memorize that one as well. Questions so far? Not too bad, hopefully. Okay, a couple other kind of special log rules. Okay, first one, we have number 7, I think. 7. Okay, try log of 1. Log of 1. What's missing? The base 10. Okay. So again, 2 different ways you could do this. Okay. First way is to rewrite this with an x. So 10 to the x equals 1. 10 to what power equals 1? X would be 0. Okay. So you could do it that way, or you could look at this as a seagull problem. 10 to what power equals 1? Okay. You could rewrite this as log base 10 of 10 to the 0 power, okay, because 10 to the 0 is equal to 1, and then you could make it a seagull problem. Your answer is 0. Okay, so you could look at that either way. Logs are going to be somewhat confusing or frustrating for some people because there is a lot of times more than one way you can get the right answer. Okay, and that's okay. Either way is totally fine. Okay, try another one. Number 8. So these are all pretty short examples. How about log base 5 of 1? Again, turn this into a seagull problem. Log base 5 of 5 to what power equals 1? 0. Okay, seagull this away. Answer is 0. Okay, this leads me to the next rule. Basically, log of any base of 1 will equal 0. Okay, that's just one that you can kind of memorize. Log of any base of 1. Any base of 1 is going to give you an answer of 0. You can kind of just memorize that one. Okay, try another one. I know these are kind of long, but you'll live. Try log base 7 of 7. What is log base 7 of 7? What's the missing exponent there? This is missing an exponent of 1. Okay, it's like an invisible exponent. This can be a Siegel problem. This goes away, answer is 1. And that's it. Okay, those Siegels are going to come in handy if you remember them. Okay, so this is another rule. And the rule basically says that log of any base to the same answer equals 1. Okay, so anytime the exponent is missing, it's always presumed to be an exponent of 1. Questions on how I did that? Okay, like I said earlier, I apologize, these are kind of long notes. Okay, so we already decided that the common log was what? Is base 10. Okay, the common log is base 10. Okay. There's another log, though, that you need to learn about. And this is something called the natural log. Okay, the natural log is something called base E. Okay, and I have a degree in business. Whether or not you like it, if you have any desire to go into any sort of business, you will have to deal with logs. Okay, and you will have to deal with something called base E. You need to know that E is approximately, E is kind of like pi. Okay, it's one that never actually ends, but E is approximately 2.718281828, and it keeps going. This is not something I want you to memorize. Okay, I don't want you to memorize the value for E. It's not like that memorizing pi and saying like 3.14 and keep going. Okay, don't memorize this. Just know that the natural log is used in business. Okay, and you need to know that there is a rule, and we will use natural logs. Okay, natural logs are written as ln. Okay, lny equals x. So ln, I don't know why natural log is written as ln instead of nl. I have no idea. It's just written that way. Okay? This, anytime you see ln, the first thing you need to do is rewrite it as log base e of y equals x. Okay, so first thing you need to do, anytime you see ln, is replace it with log base e. Then, how would you write this in exponential form? E to the x equals y. So the rule there is that you need to know how to change these from natural log form to exponent form. Okay, and the reason you have to know how to do that is you're going to have questions that ask you to simply write in exponential form. So this is going back to what we did in the first set of notes. Okay, so write in exponential form. For number 10, write log base pi of 31.01 equals 3. Write that in exponential form. You are not solving, you're just rewriting it in exponential form. So this is just like what we did yesterday. How would you write that in exponential form? Anyone? Tyler, any idea? 3 is the exponent on pi that makes 31.01. That's it. Just rewrite it. Okay, we're just switching forms. 3 is the exponent on pi that makes 31.01. That's your answer. And if you did that on your calculator, that's correct. Okay, try another one. Same thing, I just want you to rewrite this in exponential form. Natural log 20.01 equals 3. Natural log 20.01 equals 3. Okay, what did I say? The first thing you have to do whenever you see the word natural log or ln. Replace it with log base e. So log base e of 20.01 equals 3. And then rewrite this in exponential form. Thomas, how would you rewrite this in exponential form? Good job. E to the third equals 20.01. And there is a button on your calculator for E. You don't need to use it though. Okay. In fact, you don't want to use it. It would create more work for you than you'd like. Okay. Anybody have questions? I apologize. I know these are very long notes. Okay. Last thing we're going to do today is graphing logs. Okay. And I'm only going to do one. Okay, so graphing logs. Okay, when you are graphing, there are 3 steps. First thing you want to do is rewrite in exponential form. Rewrite in exponential form. Then second, you want to make a table of values. And lastly, you want to plot points and connect with the curves. Okay, so plot points and connect with a curve. So last one, are we on 12? Yeah. Okay, I want you to graph y equals log base 3 of x. Y equals log base 3 of x. So first thing you need to do is rewrite this in exponential form. So how would you write that in exponent form? Y is the exponent on 3 that equals x. Okay, then we want to make a table of values, so you're going to make your xy table. Do you guys remember when we did the exponential function graphs? Which one do you plug into? You plug into x or y? You actually plug into whatever's in the exponent. So here we're going to plug into y. So I'm going to pick 5 values. We always do 2, 1, 0, -1, and -2. And then we're going to plug in. Okay, so this is exactly backwards of what we did in 8a. Okay, so this is really like 3 squared. So your x value is 9. 3 to the first gives you 3. 3 to the 0 is 1. 3 to the -1 is 1/3. And 3 to the -2 gives you 1/9. Then we actually want to graph this. So if I'm going to graph this 9, 2, that means I have to go out 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So over 9 up 2. Over 3 up 1. Over 1 up 0. Over 1/3 down 1. And over 1/9 down 2. So if you connect these are exactly inverse of an exponential function graph. Okay? A whole number graph, was that increasing or decreasing? Increasing. So the exponential graph looked like this. This is your log graph. Okay, they're exactly inverse of one another. So this one's going to get really close to the y-axis. This one got really close to the x-axis. Okay, so this was an exponential graph. And this is a log graph. Okay, so most of you finished 8B.2 homework. What you're going to do for homework on this one is you're working on worksheet 3. You're doing numbers 1 through 18 and 22 and 23. Okay. 1 through 18, 22, and 23.